Welcome back to my channel BK Tech. So today we are going to solve the problem find the number of islands. So let me first tell you what this problem is. So we are given with a grid of size n cross m, where n is the number of rows and m is the number of columns in the grid. Where we are having a zeros which denotes us the water and ones which denotes us the land. So basically we need to find the number of islands in this. So if I tell you the how the island is defined in this question is that an island is either surrounded by water or boundary of grid and is formed by connecting adjacent lands horizontally or vertically or diagonally. So if you see this one, the explanation of one example they have given. So if you see this one, it is having a diagonal one as this, and this one is having at its neighbor as one this one, and at its diagonal this one, and in the same way this one is also having a neighbor of this one, which is connected. So this whole one and the one which are connected with all of them and highlighted in this question are is considered as a one island. In the same way, if you see whoever ones are connected with their neighbors in the form of diagonally or horizontally. So if you see diagonally, this one is connected. If you see horizontally, this one is connected. In the same way, these ones are connected vertically. So vertically neighbor. So these are considered as a island of them. So we need to find that in this matrix how the number of island are there. So for this we can use a BFS. So because this is a graph problem, so we can use a BFS here. So first what we are going to do in this is that first we are going to traverse this matrix and find out the where is the one is present in this matrix. Why we are doing it, the thing is ki, whenever we are going to find any one, we are going to call the BFS on this, so it will be able to find the which are other ones present at its neighbor in all the eight direction. So what we are going to do is that first we are going to make one for loops which will traverse this matrix. So first we are going to make a for loop which will run till we can have a size of that. In size row and size column, we are storing the length of the rows and column. So now we are going to traverse this. And another for loop in this, with which we are going to traverse each and every inner matrix of that. And here we are going to check that if one is present, one character is present in that matrix or not. And we also need to check that it is visited or not, because like if you call the BFS for this function, then all these ones which are connected as a neighbor of this one will be visited. So we don't need to call the BFS of these ones again and again. So we are going to create one visited array. Now if this condition satisfies, then we are going to call the BFS, where we can keep, I think, grid I row and columns, and we are going to pass a visited array in this. Then we are going to create one function for BFS which be which have a return type of void, because we don't want any return from this. Then we are going to mark the node which are we are calling for that first time. Like if we are calling this node or the row and column, so this we will mark it as a visited. Then we are going to create one queue, because we know that in the BFS we need a one queue where we can have a store the pairs of row and columns. So for that we need to create one more class, which I can name a pair. Then we are going to create one constructor. Now we are going to create one queue, and we will put first element in our queue, which we have called with the element which we called with the DFS. So we are going to put that into the queue. This we are going to create one object of the pair, then we are going to put that into the queue. Now we are going to run a while loop on the this queue, and we are going to fetch the peak element in this. So now we have fetched the peak element from that. Now we can remove that element from the our queue. Then we are going to traverse this. Now once we get the element from the peak element from the queue, now we are going to see who are the neighbor sets of that element in the 8 direction. So we are going to make traverse in that. And in the same way we are going to do for the columns. And again we are going to check that this is visited or not, and then we are also going to check that it's not out of bound. Like for this one, the if we see the diagonal element in upper left, so it will not be able to exist, and if we see the above element, so it will not be existing. So we don't need to go for a run loop for this, so we need to check that, and we are going to subtract the indexes from that. So we have now retrieved the delta row and delta column. So now we are going to check that condition on this, that it should be greater than equals to 0, and and column has to be greater than equals to 0. We have to put end in this. Then we are going to check if it doesn't need to be greater than the size of the grid. So we are going to fetch the size of the grid with the help of length. In the same way we are going to fetch the columns. So now have got the length of the grid, and we have got the length of the column of that. So sorry, the inner matrix column of that. So now we are going to check this. So we have verified that it is not going the out of bound. So now we are going to this has to be removed. Now we are going to check that if one is present at that index or not. If one is present, then only we are going to go on that index in that uh, if condition. Otherwise we are not going to go inside of that. So and is also need to be print. Then we are going to check that it is visited or not. Equal to 0. It should not be visited. Then only we are going to add this into our queue. So queue dot add new pair, and we are also going to mark this as a visited. This is done, and now we are also going to create one variable which will count the number of times it visited this if condition. The number of time we visit this if conditions satisfy if condition, that will be the number of islands we are having. And we are going to return this. So now we can run compile this code. So now our code has compiled, so and it is giving a correct output, so we can submit it. So you can see it has passed all the cases. I have attached the code into the description of my video also, so you can check from there also. Thank you for joining, and let's meet in the next problem solving for the graph.